Hi, my name is Jaskon Singh, and today I will be presenting section 13.2, Limits and Continuity. For our first example, we must find if the limit actually exists. To do this, we must first just substitute the values in. We find that's an indeterminate, which is 0 over 0. So that means this particular method doesn't work. So we must use another method. In this particular case, we can rationalize the function by multiplying by the conjugate of the denominator. So doing the following. And we already see that there's a common factor that might cross out. Okay, so now the new limit would be the following. And for this, we just simply put in the values. Okay, so we get the value 2. So now we know that the limit as it approaches the point 2 comma 1 is equal to 2. Okay. For our second example, we're going to demonstrate how we can use polar coordinates in a limit. We must know that x is equal to r times cosine of theta and y is equal to r times sine of theta. So we just incorporate these. So at this point, xy is going to 0 comma 0. We can put r is going to 0, and then we just plug in these over here. So we do the following. Okay, and we continue just to simplify this. Alright, keep on doing this. Right here, we can substitute cosine squared plus sine squared with 1. That's a trig identity. Okay, and we keep on doing this. At this point, we can cross out some of the r's. Okay, and now we can just simply put in the 0, which will give us the value 0. And so therefore the limit as x and y head to 0, 0 is equal to 0. In this next example, we must not only use polar coordinates, but also L'Hopital's rule. Okay, and as previously mentioned, that x is equal to r times cosine, y is equal to sine theta times r, like that. Okay, we do the limits as x and y, as r goes to 0. And we just plug it into those values right there. So that would be r squared cosine theta squared. And the following, I'll just put it underneath right here. All right, and now we just continue to simplify. And we can just take out the r, so that is the trig identity cosine squared theta plus sine squared theta. And we can do the same right here. All right, and then we go on to the next part. All right, and now we can simply put in the values. And as they head to infinity, it is 0 times infinity. Oh, I'm sorry, as r heads to 0, it's 0 times infinity. And in order to use L'Hopital's rule, you must have infinity over infinity or 0 over 0. So we must put, in this particular case, infinity over infinity. So we can do the following. Okay, and we can do it like this. Okay, so we got infinity over infinity. And at this point, we can use L'Hopital's rule, where you can take the derivative of the top and the derivative of the bottom, and you can use those to find the limit. Okay, so we have to find the derivative of this and this, so that would be following. And at this point, you could just simply put in the values, and that would be equal to 0. Therefore, as the limit heads to 0, 0, it is equal to 0. For this last problem, we are trying to find the continuity of this problem. And by definition, a function of two variables is continuous at a point in an open region if the point is defined and is equal to its limit as it approaches that point. So in this particular case, we can see that the only point in which this function is not continuous is 0, 0, 0 and is restricted from the domain. But not continuous here. Okay. Thank you so much for watching.